Hello, this is a video for Unit 3, Day 8. Sorry I'm not able to be in class today, but like usual, here's a warm-up question. Friday we started talking about linear systems of equations, 3x3 systems. So if I wanted to solve these three, maybe just write this down in your warm-up log just as practice, more review from Friday. Remember what my steps are. So my first step is to take any two equations and eliminate one variable. Doesn't matter which two I take. So let's say I take this one and this one. So 2x plus 3y minus z equals 5, and x plus 4y plus z equals 12. Now the reason I chose those two is because I noticed that one had a plus z and one had a minus z. So if I just add those two equations together, they become really easy to eliminate. So the z's cancel, and I would have 3x plus 7y equals 17. So there's one equation. Okay, so now next up, I need to take two other equations and eliminate the same variable. Looking at what we've got, if I want to eliminate z again, which two equations would you pick? Hopefully you're saying that one and that one, the second and third, because they have that same minus z plus z thing going on. So I would take 4x minus y minus z equals -1, and x plus 4y plus z equals 12. And the z's cancel. And I have 5x plus 3y equals 11. And there's my second equation. So now I have two equations, both with only x's and y's. So our next step was to take those two equations and eliminate one of those variables. And it's up to you which one you eliminate. Do you want to eliminate x or y? I'm just going to go with x. Hopefully you agree with me. So if I do that, I'd have to multiply this one by -5 and this one by +3. That would turn this top into -15x minus 35y minus 17 times 5 is 85 equals -85, sorry. And the second one would be 15x plus 9y equals 33. Add those together, x's are gone. -35y plus 26y is or plus 9y is a -26y. I gotta do -85 minus 33. I don't want to mess up, so -85 plus 33. It's a -52. Solving for y, divided by -26, we get y equals 2. So there's my y value. Now remember, once I get 1, the rest kind of come out as a domino effect. I can take that y equals 2, plug it into either of these two equations. Let's use the first one. So 3x plus 7 instead of y, 2 equals 17. So 3x plus 14 equals 17. 3x equals 3. So x is 1. And then finally, take both of these, x equals 1 and y equals 2, and plug it into any of the originals. And it doesn't matter which of the originals we use. I'm just going to choose that last one. So x is 1 plus 4, y is 2, plus z equals 12. That's really 1 plus 8, so 9 plus z equals 12. I'm going to end up with z equals 3. So putting that all together, it's a point in 3D space. 1, 2, 3. Remember, that has to correspond to x, that has to correspond to y, that has to correspond to z. Okay, so hopefully you did pretty well on this weekend's homework. If for some reason you weren't getting the answers, hopefully it's just missing little things, like it's easy to miss the negative here or there or something. If you understand the process, which again is take two equations, eliminate one variable, take a different two equations, eliminate the same variable, take those two new equations, eliminate another variable, and then plug back in for the domino effects. As long as you've got that process down, you're going to get most points, even if you do make a silly mistake. And make sure you follow it through to the end. So even if you're getting crazy answers here, make sure you're plugging in those crazy answers and getting what X and Z would be in that case. Okay, so today's notes is kind of in two parts. Hopefully, you've already been handed out this note sheet, application, linear systems, and three variables. We're going to do that second. So first, I need you to use your own paper. So if you can get a blank sheet of paper out. And this, you can label it Unit 3, Day 8. And we can call this just more problems involving 3x3 systems. Now this first example is like a problem on the green sheet. I think it's like green sheet number 2, which is due day after the test, as always. So we can use this to help you with green sheet number 2. It's a little bit different, but it's very similar. And the example is, find the equation of the form y equals ax squared plus bx plus c of the parabola that passes through the points um, 1, 6, 320, and negative 2, 15. Okay. So let's think about what we've got here. We've got a parabola that's going through these 3 points here. So I'm going to go, we'll call this 5, 10, 15, 20. You don't really need this picture, but just for a visual of what we're talking about. So 1, 6 would be right about there. 320 would be up here. Negative 2, 15 would be right here. So you can kind of picture what's happening. There's some parabola that's going through those 3 points. I want the equation of that parabola. So by giving us this general form, that's the general equation for a parabola. And we'll learn more about that in a few weeks. But for now, just know that's a formula. I'm going to take each point and plug them in for x, y. So for example, I'm going to start with 1, 6. 1 is obviously x, 6 is obviously y. Plug that into that formula. You get 6 equals a times 1 squared plus b times 1 plus c, which is the same as 1a plus 1b plus 1c equals 6. There's one equation. Now do the same with the other 2 points. So take 320. Again, 3 is x, 20 is y. Plug it in. 20 equals a times 3 squared plus b times 3 plus c. Gives me the equation 3 squared is 9, so 9a plus 3b plus c equals 20. There's a second equation. Take that last point. Negative 2, 15. There's x, there's y. 15 equals a times negative 2 squared plus b times negative 2 plus c. Negative 2 squared is 4, so that's 4a minus 2b plus c equals 15. And all of a sudden, you should see I've got 3 equations, 3 unknowns. If you look at these over here. So how am I going to figure out what A, B, and C are? Using a 3x3 system. So now, solve like yesterday. So I'm going to have to take two of these equations and eliminate one variable. Again, it doesn't necessarily matter which two I take. Let's just take the top two. We'll do a plus b plus c equals 6. 9a plus 3b plus c equals 20. What variable do you think you'd want to eliminate? I'd go with c, because we only need to make one of them negative. So multiply this top equation by -1. Gives us negative a minus b minus c equals -6. 9a plus 3b plus c equals 20. C's cancel out. We would have 8a plus 2b equals 14. There's one equation. Okay, next, let's take another two equations. Let's take the top one with the bottom one this time. So a plus b plus c equals 6 with 4a minus 2b plus c equals 15. And again, remember, we have to eliminate the same variable as the first two equations, so I have to eliminate c. So multiply by -1. We get negative a minus b minus c equals -6. 4a minus 2b plus c equals 15. There, those c's go away. So 3a minus 3b equals 9. So there's my second equation. Okay, now remember what we do with those. We take those two equations, eliminate a variable. So I have 8a plus 2b equals 14. 3a minus 3b equals 9. Which variable would you eliminate? I'd get rid of b because one of them is positive and one of them is negative already. So why don't we multiply this one by, what do I have to multiply by? I want to get rid of b. 3. And this one I have to multiply by 2. So I'd get 24a plus 6b equals 3 times 14, which is 42. And on the second line, I'd get 6a minus 6b equals 18. 6b's cancel. I get 30a equals 42 plus 18 is 60. So a is 2. Once I've got a, what do I do? Well, now I can plug it into either of those, figure out b. Let's use that top one. So I'm going to do 8 times a, which is 2, plus 2b equals 14. So that's 16 plus 2b equals 14. And 2b is -2, means that b is -1. And then I got to take a and b, plug it into one of these originals. Which one would you want to use? First one, def, looks the easiest to me. So let's use a plus b plus c equals 6. So a is 2, plus b is -1, plus c equals 6. So that's really 1 plus c equals 6, so c is 5. Make sure you actually answer the question. So we found a, b, and c. Now if I go back to the top real quick, I'll come back down in a second. I want to define the equation. So I want to use this ax squared plus bx plus c. Now I know that a is 2, b is -1, and c is 5. So my answer is going to be that equation with those plugged in. So my solution is y equals 2x squared minus 1x, or just minus x, plus 5. Okay, so hopefully that made sense. If I wanted to check real quick, there's a way I can kind of do it with my calculator. If that's a parabola, supposedly these 3 points are supposed to be points on that parabola. So as a quick little check, why don't you go to your calculators and go y1, put in 2x squared minus x plus 5. So Here's my calculator. Y equals, figure out anything that's in there. 2x squared minus x plus 5. So 2x squared minus x plus 5. I'm just going to zoom standard. There's the parabola. And I want to see if those points are actually on the graph. So there's a couple ways I can do that. I can hit trace and type any x value I want. So let's see what x values I actually wanted. I wanted 1, 6, 320, and negative 215. So I'm going to hit the trace key. Type 1, see if I get 6. Then I'm going to type 3, see if I get 20. And I'm going to type negative 2, see if I get 15. So I just have to hit trace, type 1, and I get 6. 1, 6, that's what I wanted. That's great news. Type 3, so hit trace, type 3, hit enter, 320. So my second point was on the graph, 320. And the last one, trace, type negative 2, hit enter, negative 215. All those points that were supposed to be on the parabola are, so I'm very confident that we got the right answer. Okay, so again, that's very similar to a question that's on your green sheet. If you look at number 2 on your green sheet, same setup, except it's the equation of a circle instead of a parabola. We do the exact same process, get your 3 equations, and then do one of these problems out. Okay, if you can switch over to that worksheet that was handed out, and I think mine's back this way, application linear system in 3 variables. This is just a word problem that's going to come into being in one of those linear systems. So it says a restaurant owner estimates that she needs in small change the same number of dimes as pennies and nickels together, and the same number of pennies as nickels. If she gets $26 worth of pennies, nickels, and dimes, how many of each coin does she have? Okay, so I've got to kind of translate this into some equations. I want to know how many of each coins. So she's got pennies, nickels, and dimes. So those are going to be my 3 variables, P, N, and D. So she needs in small change the same number of dimes as pennies and nickels together. So number of dimes, which is going to be D, it's the same as pennies and nickels together. So what would that look like? D has to equal number of pennies, P, plus number of nickels, N. So D equals P plus N. Next it says she needs the same number of pennies as nickels. So number of pennies is the same as the number of nickels. How would I write that? P equals N. And then finally this last one. She has $26 worth of pennies, nickels, and dimes. So we've got to say if I've got 1 penny, or however many pennies I have, they're each 1 cent. And however many dimes they have are each 10 cents. However many nickels are each 5 cents. So I can express that as number of pennies times 0.01. So pennies times 0.01 plus number of nickels, N, times 0.05. So 0.05 N plus number of dimes, D, times 10 cents each has to equal $26. Okay, now technically here I have 3 equations with 3 unknowns. It might make more sense if you have them all equal to a number on the right. So this first equation is equivalent to saying P plus N, subtract the D over, minus D equals 0. If I subtract the N over, I would have P minus N equals 0 as well. And this third one's already set up in the order I like. 0.01P plus 0.05N plus 0.10D equals 26. So again, the only reason I did that is because anything I normally do, any question like this you've normally seen, has all the variables on the left and the numbers on the right. Okay, so now I'm ready to eliminate. What variable would you like to eliminate? Well, just looking at the top 2, eliminating n seems pretty easy there. So let's do p plus n minus d equals 0 with p minus n equals 0. If I just add those together right away, the n's are gone, and I have 2p minus d equals 0. So there's one equation. So now I've got to eliminate n again. So I'd maybe take the second two equations, p minus n equals 0, and 0.01p plus 0.05n plus 0.10d equals 26. In order to eliminate n, what would we have to do? We'd have to multiply this by 0.05. So I'd have 0.05p minus 0.05n equals 0, and then 0.01p plus 0.05n plus 0.10d equals 26. Add those together. N's are gone. This is what I wanted. I have 0.06p. Oops. So got that plus 0.10d equals 26. There's my second equation. Okay, hopefully this is becoming an old trick by now. Now I've got to take these two equations, 2p minus d equals 0, and 0.06p plus 0.10d equals 26, eliminate one of those variables. What do you think is the easiest to eliminate? Definitely d. So I want to multiply this one by 0.10. And if decimals mess you up at all, just to be safe, you don't want to make a mistake, 2 times 0.10, which comes no shock, is 0.2. So 0.2p minus 0.10d equals 0, added to 0.06p plus 0.10d equals 26. So the d's are gone. 0.26p equals 26, divided by 0.26, and p equals, hopefully you know that's 100, in case you don't, 26 divided by 0.26, it's 100. So I got 100 pennies. And now I'm to my step where I'm just going to start back substituting. So p is 100. I can plug that into, this looks like the easiest equation to work with over here. So let's use that one. 2p, so 2 times 100 minus d equals 0. So 200 minus d equals 0. Add the d over. 200 equals d. So we got 200 dimes. And then finally, plug both of those in to one of the originals. Solve for n. Now technically, I only need n. I can use this equation. 100 minus n equals 0. 100 is going to have to equal n. So make sure we answer the question, how many of each coin does she have? We've kind of done that. She's got 100 pennies, 100 nickels, and 200 dimes. Okay. Hopefully no questions. Lots of more practice with those 3x3 systems. Your homework tonight's a worksheet. And let me pull that up for you real quick. Now, I'm not sure if you have the homework in front of you, but this is what the homework sheet will look like. It'll be passed out to you shortly if you don't already have it. Just to talk through it really quick so you don't have problems tonight. This first question, literally exactly the same as the first one we did in the notes today, just with different numbers. So hopefully you can follow through those first questions from the notes. Find the equation of the parabola. Number 2 is an application question. We'll come back to that in a second. This is one more solve a system like you did yesterday, so that should be no issue. But I just wanted to talk about this real quick because this throws people off a bit. It says Mr. Laley is shopping for new school clothes. He needs to buy an equal number of shirts and ties. He also needs to buy 4 times as many shirts as pants. Shirts cost $35, ties cost $25, pants cost $40. Mr. Laley pays $560. How many shirts, pants, and ties did he get? Now, I'm not going to tell you everything here because he needs to buy an equal number of shirts and ties. I think you should be able to figure that out. Maybe call shirts S, ties T. He also needs to buy 4 times as many shirts as pants. Now, that's what messes people up. So let's think about that for a second. Here's my shirts. Here's pants. I need 4 times as many shirts as pants. So if I have 1 pair of pants, how many shirts do I have? 4. If I have 2 pair of pants, how many shirts do I have? Well, 4 times that, so 8. If I have 3, how many shirts do I have? 4 times that is 12. So in general, if I have P pairs of pants, I have 4 P shirts. So the number of shirts is equal to 4P. So that second line means I'm going to have this equation, number of shirts is equal to 4P. A lot of times if we don't think it out, people put it the other way around. They'll say P equals 4S, 4 times as many shirts, but it actually is S equals 4P. So needs to buy an equal number of shirts and ties. So this, I think you should be able to figure out an equation for that. I just did the second one for you here. And then if shirts cost 35, ties cost 25, pants cost 40, for a total of 560, there'll be a third equation that you can get based off of that. And that should be similar to the pennies, nickels, and dimes that we just did. Okay, so hopefully that gives you a good starting point. Check your answers on that blue sheet, and you'll know if you've got them right or not. Good luck.